Note scenario. Okay. All right. So, boom. All right. Then we actually have a kind of a good first example of that crazy or your shifty Uncle Larry as far as a loaded dice or a bad coin. But the whole idea of like kind of what I talked about yesterday about theoretical compared to experimental. And I did say this yesterday in those notes. If I roll a dice and five keeps coming up, and I roll it 100 times and five comes up 60 times, there's probably something wrong with that dice. That's not likely to happen. What's likely to happen is 1/6 kind of as you go. In the law of large numbers, the more you do it, that 1/6 per each number will start falling into place. If it doesn't, then something's going on with that coin or that dice in that example. So experimental probability. There, you got to get my draw. You use data. I'm just going to say data. Hard to write with this angle here. From an experiment. So theoretically, you do nothing. You just you calculate the odds, what's likely to occur, and then you use that to make predictions. To calculate probability. And I'm going to be short on that. Calc the probability. So it's a little different. The probability of any particular event is the number of observed outcomes. You actually observe something divided by the total number of trials. Okay, and then I don't have to overdo that here. Let's just go to this example. Here we go. All right. Here we go with something that is quite, large here as far as one of the numbers, and it's one. I could observe this and say one kind of happened a little bit more than the others. So, does this mean the dice is not necessarily, legitimate? Maybe, maybe not. What probably would happen is you do more than these rolls. But did anyone calculate these? I see some people punching the buttons. How many rolls are there total? I saw some people hitting their calculator. Could you tell me? 300 on the dot? Oh, it says so right here. My bad, dogs. All right, so there's 300 rolls. When I look at one, that's almost 1/3 instead of 1/6. So at this point, I'd be scratching my head: is this dice legit or not? Probably law of large numbers. We probably keep rolling it and see if this keeps happening, or do things as we get larger? Does it start to sink into the 1/6 thing? But anyway, it's the experimental probability. So you roll an even number, all right? So basically, all I have to do is add these up. So it's not using the dice idea where you should get rolling an even should be a half. Let's see what we get out of this dice. So it's 31 plus 36 plus 6 is 46. And then that's divided by 300. All right, 70, 30, 60, 100, 106, 112, 113. Is that right? And then what is that as a decimal? Could somebody calculate that real quick for me? 0.3766. Let's say 0.377. Right? And then stay on the page. It's supposed to be a half. All right. So it would cause a little concern on this dice. Maybe more rolls. 300 may not necessarily be enough, but All right. Roll a perfect square. Okay. What are our perfect squares on this list? What numbers represent a perfect square? Is one a perfect square? Yes or no? Yes, it is. Whoever's shaking her head. What's the square root of one? One. And that drives me nuts when seniors write square root of one as a final answer and circle it. Yeah. Square root of one is one. Square root of four is two. So we do have these two as perfect squares. 2, 3, 4, or 5, and 6, not so much. So perfect square. Probability of a perfect square. Lost my pen. Love you, pen. Equals 98 plus, getting chicken scratchy here, 36 divided by a hundo, or 300, I'm sorry. All right, it should have been 2 out of 6, which is 1/3. And I think this one's a little bit closer to that. So 90, 100, 126, 134, right? Maybe a little bit off. Could someone take 134 divided by 300? All right, maybe a little bit too big. 0.446. Is that rounded correctly? This. Oh, so it'd be 7. I mean, right? If I went 3 decimal places. Someone might ask, where should I round? I don't know. I'm going 3 decimal places so that if I change it to a percent, it would be 44.7%. It would at least have a decimal percent in there. Okay, and then the old classic roll of 5 or a 1. What do we do with the word or? Always add, because you're only doing one roll when it says that. All right, so, but what's probably get this or that, blah, 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 blah. So that is 25 over 300 plus, and then 1 is 98 over 300. Then with that 98 being quite high, this is going to be a little bit skewed probably. Well, the 25 is kind of low, so that's interesting. 98, 108, 118, 123. And then what's that as a decimal? A little closer to 1/3 point. 41. And that's it. It went 0, 0. Yeah. Yeah. Okay. All righty. Trust you. And then you do not roll a 3. So that means you roll everything else. This is kind of like a complement, the opposite of. So if not rolling a 3 is rolling everything else but a 3. So very simple. So 98, 31. Go ahead and add these for me too. 36. So really it's simple. This is why we probably should do a couple different things today, but you know what? It's a Friday. We'll take it easy. Or I could have done 1 minus 64 over 300, and that would have been just as easy. What do you get as a decimal? Let's just go ahead and get to that. 0.787 or 78.7%. Okay, not a big deal. All right, now just reading a chart real quick. Blood samples, sample donors at a blood drive are displayed in the bar graph. I don't even know my blood type. How many people know their blood type? That's interesting. Really? I don't even know what mine is. That's wild. I can't even think what it might be. But find the experimental probability that a randomly selected blood donor would have a blood type of O. Okay, so very simple on that one. Get the total, which is 43, 48, 50, I think. Did I count that right? So it's very simple, 22 out of 50. Let's move on. I know that one, 0.44. Very simple. Double 22. 22 over 50 is 44 over 100. So 0.44. All right. So box contains blah. You randomly draw out 10 markers and 4 of them are purple. Compare the experimental and theoretical probabilities of randomly choosing a purple marker out of this. So, theoretical and experimental. So, theoretical. Okay, you draw out 10 markers and 4 of them are purple. Okay, so you have a total of 40 markers and 15 of them are purple. Okay, so I just want to make sure I got this right, what I'm doing. So the probability of getting a purple marker, theoretically speaking, is 3/8. So that should be the theoretical thing that should happen here when I'm pulling out one marker at a time. The experimental probability, you pulled out 10 markers and 4 of them were purple. So it happened 4/10 out of this experiment here. All right. So what happened experimentally is 40% of the markers that I pulled out were purple instead of that 0.375. So pretty close. Um, so therefore the experimental was just a little bit bigger than the theoretical. All right. And that's likely to happen. You're not going to land on it right on the dot, so to speak, but at least it's kind of close. So that's really all we have to say about that one. So we can move on. All right. I did kind of talk about the complement. Ooh, I should have more of these. There's your dice. Okay. So I gave you that yesterday, more square looking than this picture, but we're going to get to that here in a moment. All right. So complement is, you could think of this as opposites. And I did kind of bring up that word earlier when we had this previous one here. And we're almost done here, so going pretty fast. You do not roll a 3. Well, I added up all the possibilities of not 3, or we could have done 1 minus rolling a 3. And then that's the complement of not rolling a 3. So that's where that word comes from. Complement means opposite of what we are looking at. So consists of all elements not in A. Really want you to focus on those two symbols, mostly this one. This is the one I've seen in every single stats book I've ever dealt with. A line above A means not A. So that's what this means. What's the probability of not A? Then I guess this newer one, that just is more specifically complement of A. They mean the exact same thing. But every stats book I've ever seen is the bar A. All right. So be aware of that. All right. And then quite simply, the probability of not A is 1 minus the probability of A. All right. Because it's the exact opposite of that condition. And you might want to use that sometimes. You might want to have used it on that last example before the blood donor thing. All right. So, question. Okay. Okay. So, complement means, I guess, opposite. That bar A means not A. And again, I've seen that in every book I've ever dealt with. That AC is kind of new to me, probably new to that, or for this particular author, they made up a new symbolism. I've never seen that before, right? Until this book that we had last cycle, not the book that you guys have now. There's a book. I know we don't use it too much. All right, that should be good. All right. So the whole idea of dice rolling 3 or 2 dice instead of 1. 1 dice, there's a 1/6 chance. All right, not teaching you to gamble. Again, I teaching you the opposite. You always lose in the long run when you gamble. But this is the basis of craps in a casino. They roll 2 dice, and these are all the possible outcomes. Double ones, that's called snake eyes, everybody. If you go to the gambling. Hey, does anyone know what 2 sixes are called? No? Do you know? You're shaking your head. No, I thought Alejandro was shaking his head. Those are called box cars. This is not on the test. All right. So anyway, 2 dice rolled. There are 36 possibilities. So the point of them making it white and red dice, it's different when one dice gets a 1 and another one gets a 4, or the first dice gets a 4 and the other one gets a 1. There's 2 possibilities of getting 4 1. They are counted because you have 2 different dice that could occur. So that's the point of the book, making it white and red, so you understand that there's one dice and a second dice, and those are different. All right, so then a sum that is not 6, where we have to look is, where do I get a sum of 6? And I'm going to use my highlighter, I guess, and that is right in this diagonal, right? And I don't see any others because the other diagonal is 5, then it goes 7. Maybe I am missing one. Sorry, my bad, dogs. Nope, we're not. 6, 8. This one's 9, 10, then 11, then 12 on there. So that's the only diagonal that occurs. So a sum that is not 6, what I'm going to do is 1 minus 1, 2, 3, 4, 5, 5/36, the opposite of this. All right. And then that ends up being 31/5. Hopefully you can, or 31/36. I'm sorry. Hopefully you can do the common denominator in your head and then get that really quick. All right. The sum is less than or equal to 9. Less than or equal to 9. Here are your nines. And then it's all of these. Okay, so all of those are sums less than or equal to 9. Instead of counting those, I would do 1 minus the unshaded. Come on, pen. You can see me hitting this. That works. I found a new thing. Just slam the back of this pen and it actually activates it. 1, 2, 3, 4, 5, 6 36ths, which actually is 1/6. So I know 1 minus 6/36 will be 5/6. So I did reducing, and then I did a common denominator, and that should not be a big deal. 6 goes into 36 6 times, so this is 1/6. So 5/6 chance of that happening here. All right, if you need your deck of cards, go ahead and look at that sheet. Given a standard deck of cards, what's the probability of not drawing a red 2? First of all, how many red 2s are there? I guess you don't need that sheet. How many red 2s are there? 2. There's actually 2, a heart and a diamond. Okay, so 2 50-seconds would be drawing a red 2, not a red 2. Should have reduced again. Is 1 minus that. So it's an idea that you want to use actually. The probability that it rains on any given day is 74%. What is the probability that it did not rain on Tuesday? Big deal. 1 minus 0.74, which is 0.26 or 26%. All right, and then the same thing with this probability of a woman has her first child before the age of 26 is 33%. What is the probability that a randomly selected woman has her first child when she is at least 26 years old? Okay, so that a randomly selected has her first child when she is, what does at least 26 mean? That means 26 or what? Older, okay? So that means 26 or older, which is the opposite of what this is saying. They would have a child before the age of 26. That doesn't include 26, is 33%. So 26 or after is the complement of this. And then feel free to change that to a percent if you wanted. Okay, it's a real light day on a Friday. You probably could be done with your worksheet before you finish. I'll maybe have a key with it, but I'm going to go ahead and stamp, and then that's what we can accomplish today.